what is this OSI reference model? If we were to look back at the early days of when networking was evolving, it was quite chaotic. And the reason is because you had different vendors that had their own proprietary solutions, right? I'm going to do things this way. I'm going to do things that way. So here's a good example, right? Look at, in fact, yesterday I was sitting somewhere and somebody was sitting beside me and they forgot their power cable for their laptop, and nobody else had a power cable that would fit into his machine. And if you think about all the options that there are for power cables, right? Just look at all the different laptops you have. Even you get this with HP. I have an HP. There are 4 or 5 different power adapters. Then you look at the iPhone versus the Android, the USB, and the iPhone power kit. These are vendors who have just come up with their own way of doing things, and makes it very difficult for the rest of us to then do things uniformly. The one uniform thing is that we have is the USB. Most of the devices can extract power from USB, and the 120 volt power outlet. So those are standards. Everyone decided, look, we don't want to have all these different things going on. We want some standards. And so the same thing happened with networking. Each vendor had their own proprietary solution on how communication would take place over networks, and it just became very chaotic because one vendor solution wasn't necessarily compatible with another vendor solution. So this is essentially where the idea for the OSI model was born. And the idea was to have a layered approach to networks, so that hardware vendors would design hardware for the network, and then others could develop software for the application layer. And using more of an open model, so one that could be adapted for different types of technologies, but everyone could agree to, and we could build networks that were compatible with different devices, and build networks that were compatible with each other, because again, we have to connect networks to networks at the same time as we have to connect devices and nodes to networks. So to fix the problem, there's an organization called the International Organization for Standardization. I don't know if you've heard of that, but it's ISO. So OSI and ISO, they're kind of one is, they're not related, but they have the same letters in them. But the International Organization for Standardization, ISO, looked at different network models, and the result was this OSI model, which was released all the way back in 1984, when maybe some of you weren't even born, if I were to guess. But nowadays, more vendors build networks based on the OSI model, and hardware vendors create these networks and these devices so that all of this is compatible. And it's all thanks to this OSI reference model. So before I show you the next slide, which is kind of the model itself, think about if you had to send, I'm not going to say a letter, let's say a package, okay? Because we deal a lot more with packages today than we deal with letters. So, you need to get a package from somewhere, from Amazon, right? There's a certain number of steps, or you need to get a package from, I don't know, where else are we getting packages from Grubhub, or, wherever they need to come from. There are certain steps that have to take place in each case, right? And if you're dealing with packages, the steps are very similar. If you're dealing with food, the steps are very similar. Each vendor has their own little twist on things and take on things. But in general, if I'm getting a package from Amazon, I have to order something. They have to get whatever it is. They have to package it. They have to put my address on it. They have to give it, they have to take it somewhere or put it somewhere where the shipping company or the courier will pick it up. The courier company then has to take it to their depot. It has to be sorted. It has to be sent somewhere, and so on. So there's this series of steps that occur. It's not just some random, oh, I'm going to call Amazon, order this, and somebody's going to bring it to your house in some random fashion. There's a very systematic way of doing things. So the OSI reference model creates this systematic approach in layers. Okay, so it breaks up the layers, or breaks up the network in layers, and it gives some responsibility to each layer, and then the layers above have to do things for the layers below, and then the layers below have to do things for the layers above, because we're going to go down, across, and then back up. Okay, that's how the communication works. We start at layer 7, we go down to layer 1, end up at the other device, and then go back up from 1 to 7. Okay, so you can think of the OSI model as the universal language for computer networking. It's based on the concept of splitting up the communication system into 7 abstract layers, each one that's stacked upon the previous one. Okay, looking at that this way, you can kind of get an idea of what those tasks are and why they need to be separated, or what's the benefit in separating them. And as the complexity of computer hardware and software increases, the problem of successfully communicating between these systems becomes more difficult. So dividing these difficult problems into subtasks allows them to be readily understood and solved much more easily. Using this layered approach means that a vendor can work on the design and debugging for a particular layer without affecting others. Right, so you can be involved at any point in any of these layers, and as long as you work within the rules of what that layer needs to do, and your output is compatible with what's required by that layer, and you know what kind of input you're getting, you're free to do whatever you want in that layer to make it faster, better, more optimized, custom to your solution, whatever the case is, as long as you are within this framework. Okay, that's where the beauty is. That's why we're able to create such large universal networks. And generally speaking, the upper layers, so when you look at layer 5, 6, and 7, that's where you have more involvement or the involvement from the operating system and the applications and the software. And then when you get down from layer 4 down to layer 1, that's where you get into the network and physical media. And somebody asked earlier before, what's the difference between a router and a switch? And I was trying to see if I could find an easy way to explain it. And we're going to need a little bit more reference before I get to being able to explain that difference. But one of the differences between them is the layer at which they operate. One is going to operate at the transport layer, one's going to operate at the network layer. So when we get through some of this and some other material, we'll be able to look at what the difference between a router and a switch is. But essentially, a router is sending information to other networks, and it supports wireless, where the switch is typically focused on switching traffic within a single network, and it's limited to wired networks. But there's a lot more behind that, so we'll get to it at some point. But one of the differences is the layers at which they operate. But essentially, we have these upper layers and these lower layers. But in total, we have these 7 layers that we have to understand and focus on. Yeah, actually, so maybe we should do this here. Just go through these in a little bit more detail. So layer 7, so you can think of this as the where the human and the computer interact, right? Where the applications are setting things up to be able to access network services. So layer 7, you'll hear that a lot. HTTP is one of the most common protocols. And that's the thing about all these layers. Each of these layers has associated with it some kind of a protocol, some kind of a standard, and you have to adhere to that standard, okay? But you'll hear about layer 7 communication a lot. Is probably, the thing that you'll hear the most. But layer 7 is kind of where you kind of the application starts interfacing with the networking layer and prepares the information for the network. Okay, then you have the presentation layer, which is, and we're going to go a little more deeply into each one. So like I said, a lot of this you're going to get as it's repeated to you. So we're going to go through in detail for all of these. Just going to give you a high level overview right now. Layer 6 is the presentation layer. So layer 7 is the application layer. Layer 6 is the presentation layer. And this is what this layer does is it makes sure that the data is in usable format for the application layer. All right. So for example, if there's encryption or any compression or anything like that, that the data is ready for the application layer. And then you have the session layer. Many of you might have heard that term before, the session. Have you opened a session? How long is your session? Your session expired. So that thing in a browser that maintains the session between your browser and the server, that's managed by the session layer. And then you've got the transport layer. And this is where data is packaged up and sent using or packaged and or repackaged and sent to the next layer via these protocols like TCP and UDP, which maybe you've heard of, but TCP is the protocol that we use most predominantly with the internet and networks today. And then the network layer is going to decide which physical path the data is going to take. Okay. The data link layer is defining the format of the data on the network itself. And then finally, the physical layer is the raw stream of information that gets sent over the physical medium. Okay. So application layer, presentation layer, session layer. Then you've got transport, network, data link, and physical layer. All right, let's go into each of these more specifically. All right, so here's the 7 once again. And we will start at layer 7, the application layer. Okay, so this is the only layer that directly interacts with data from the user. So you have software applications like web browsers and email clients that rely on the application layer to initiate communications. But it should be made clear that the client software applications are not part of the application layer. All right, the application layer is responsible for the protocols and data manipulation that the software itself relies on to present meaningful data to the user. So it's separate from the application itself or from the browser itself, but that's what the browsers and the applications rely on. It relies on understanding that layer 7 protocol in order to present data properly. All right. So a couple of the protocols that you have at layer 7 are HTTP, which is the most common. And then some of you may have already also heard about SMTP, which is the simple mail transfer protocol. And that's how mail is sent. Email is sent from, across a particular email server. Okay. So this is the application layer. And you can think about application layer as predominantly, in our day and age is like HTTP communication or SMTP communication for email. Okay, and then you have the presentation layer or the presentation layer, and it's almost a little bit confusing when you sometimes think about it, because sometimes people refer to presentation as, yeah, I'm looking at my browser, that's the presentation layer, but this is the network presentation layer. So it's a little bit different. This layer is primarily responsible for preparing data so that it can be used by the application layer. So in other words, layer 6 is going to make the data presentable for applications to consume. The presentation layer is responsible for things like translation, for encryption, for compression. Two devices communicate using different encoding methods sometimes. So if I'm talking to a different computer or device with a different operating system, they're going to encode their data differently. And so layer 6 is going to be responsible for translating that incoming data into a syntax that the application layer of the receiving device can understand. And again, I just want to emphasize that some of this stuff is a little bit abstract because you can't see this. I understand it because it's also a little bit complex, or was complex for me initially because you can't see this thing. So you kind of have to just rely on the words that you're being given to kind of communicate, to understand it, and it's very hard to visualize. So I understand that, but just try and get what you can from it. You're basically taking data, dealing with encryption, with compression, with any sort of translation between devices or encoding. And like I said, so if the devices are communicating over an encrypted connection, layer 6 is responsible for adding the encryption on the sender's end, as well as decoding the encryption on the receiver's end so that it can be presented to the application layer unencrypted and readable. And then finally, the presentation layer is responsible for compressing data it receives from the application layer before delivering it to layer 5. So, like I said, it's got responsibilities going up and responsibilities going down. And why do we want to compress? Because it helps improve the speed and efficiency of communication by minimizing the amount of data that's being transferred. Now, I've said a couple of things here that I'm assuming everybody knows, but let me just backtrack for just a second here and explain it. But I use the term encryption and I use the term compression. So I don't know if everybody knows what those are, but let me just say, kind of take a little sidebar for a minute and talk about that. So encryption is a way to encode your data so that it can't be intercepted or it can't be read except by the person that you're intending to read it. So just to give you a very, very, very simple example of encryption, let's say I came up with a map, a character map, and I said, every time I get a letter, I'm going to change it to the next letter. So if I get an A, I'm going to change it to a B. If I get a B, I'm going to change it to a C. If I get a C, I'm going to change it to a D, right? So if I look at these 3 characters, let's say I wanted to send these 3 characters, instead of sending F, O, and R, I'm going to send G, O, P, and S, GPS. And I'm going to encrypt it. I'm going to encode it. So if somebody were to look at that, now that's a very simple encryption algorithm, so people would be able to figure out pretty quickly. But GPS, you can't really tell I was sending the word for, and only when it gets to the other end does the other device know how to decrypt it, so then it converts it from GPS to FOR. So encryption just means encoding or changing your message so it can't be read except by the destination. And the whole area of encryption is very elaborate and complex, but in a nutshell, that's what encryption means. And then compression, hopefully that's a little bit more obvious than encryption, but compression is you're taking some amount of data and you're just reducing the amount of data so that you don't have to send as much over. So for example, if I have this sentence, right? Again, very, very simple compression algorithm. I could just get rid of all of these spaces, and instead of the spaces, I make the next character a capital. So I've primarily capital R, and then responsible, capital F, and then capital P. So I get rid of all the spaces, but when I get to the other end, it's easy for the other end to know where the spaces need to go. They just look for the capital letters, except for the first one, and they put a space and change it to lowercase. Again, it's a very dumb, simple compression algorithm, but just to illustrate the point, because now rather than having to send 100 characters, maybe I only have to send 50 characters. And sending 50 characters is going to be half as or sorry, twice as fast as sending 100 characters maybe. So you want to be able to compress it. So that's what encryption and compression is, and that's why the network has the specific layer to do that, because it's such an important part of network communication. Okay. We have layer 5, which is the session layer. So this is the layer that's responsible for opening and closing communication between two devices. The time between when the communication is open and closed is known as the session. And you guys should all be familiar with this. Many times, I'm sure you're logged into some application or your bank or whatever, and all of a sudden it says you've timed out, your session has timed out, or it forces you to log in again, and that's the session. That's the session duration. And so maintaining that session is the responsibility of layer 5, right? So the session layer is going to ensure that the session stays open long enough to transfer all the data being exchanged, and then close the session in order to avoid wasting resources, which is one thing, but I guess more importantly in this day and age, to make sure that people don't take advantage of an open session to maliciously get data or use a system that they shouldn't be using. The session layer also synchronizes data transfer with checkpoints. So for example, if a 100 megabyte file is being transferred, the session layer could set a checkpoint every 5 megabytes. In the case of a disconnect or crash, after 52 megabytes have been transferred, the session could be resumed from the last checkpoint, meaning only 50 more megabytes of data need to be transferred. So without the checkpoints, the entire transfer would have to be, would have to begin again from scratch, right? So essentially it's sending data over, but putting some checkpoints in and saying, okay, this was sent, this was sent, this was sent. And then in the middle of it, if something happens and that session ends, then it could just pick up from where it left off rather than having to send everything again. So remember we talked about one of the features of a network was fault tolerance, right? And this is one kind of fault tolerance, right? Where if something were to go wrong, it's not going to take you a long time to recover. Whatever caused that break in connection is restored, and then you only have to send half the data over. All right, layer 4. So layer 7 is the first one you're going to hear a lot about. Everyone's going to talk about layer 7. If you're in the cybersecurity track, layer 7 threats, layer 7 protection, layer 7 this, layer 7 that. A lot of talk about layer 7. So layer 7 is the one that gets a lot of attention. The other one that gets a lot of attention is layer 4, the transport layer. Okay, so the transport layer is responsible for end-to-end communication between two devices. So this is going to include taking data from the session layer and breaking it up into chunks called segments before sending it to layer 3. Okay, the transport layer on the receiving device is then responsible for doing the opposite, which is reassembling the segments into the data for the session layer so that the session layer can consume it. Okay, so the main takeaway for layer 4 is for layer 4 is it's taking the segment or the entire message that has to be sent across, and it's breaking it up into smaller segments, smaller chunks, okay, segments. The other thing that the transport layer is responsible for is flow control and error control. Okay, so flow control is essentially going to determine the optimal speed for transmission based on the transmission media and the configuration of the network and so on, so that if, for example, you have a device on this end that's able to support very fast communication, but you have a device on this end that doesn't support very fast communication, that they're transmitting at the right speed, at the optimal speed that works for both of them. Okay, and then the transport layer performs error control on the receiving end by ensuring the data that is received is complete and then requesting a retransmission if it isn't. All right. So again, lots of things can happen to the data along the way, right? Sometimes these messages get corrupted, get dropped for whatever reason. And so being able to have a layer or a component here that corrects for these errors. So if something is sent, but it gets messed up going across, the other end will be able to know that. And again, we'll talk about that at some other point, how it does it through these things called checksums, but it knows whether that segment is intact, whether it's correct or it's not. And if it's not, it then requests a resend. Okay, and so that's what layer 4 is. So think about segmentation for layer 4. So segmentation, error control, meaning if there are any errors sending the segments, and then the other one is flow control, so to make sure that the speed is optimized. Okay, so as we go down these layers a little further, we get to the network layer. So the network layer is responsible for facilitating data transfer between two different networks. All right, so here's so one thing to remember: if the two devices are that are communicating are on the same network, then the network layer is unnecessary. So that's why I was saying the difference between a switch and a router, right? So the switch is going to operate at layer 4, and the router is going to operate on layer 3. But if the two devices are on the same network, then you don't need layer 3. The network layer breaks up segments. So it takes those segments from the transport layer into smaller units that are called packets on the sender's device, and then reassembles those packets on the receiving device. The network layer also finds the best physical path for the data to reach its destination, and that's known as routing. Okay, and I think we have a whole session on routing at some point. But routing is a big part of, it's essentially, if you think about the postal service, right? How does the postal service get you your mail in the fastest possible way? There are routing rules that it follows, and it's the same kind of thing with a network. So network, the network layer, layer 3, we could think about packets. So we're going from segments to packets, and we are doing routing, packets and routing. All right, then we have the data link layer. So this is layer 2. The data link layer facilitates data transfer between two devices on the same network. The data link layer takes packets from the network layer and breaks them into smaller pieces called frames. Okay, so we went from segments to packets to frames. Okay, like the network layer, the data layer link layer is also responsible for flow control and error control in intra-network communication. Okay, so this is when they're on the same network. And then this is the other layer that gets I should say layer 3 also gets a fair amount of attention. So 743 and layer 1. Layer 1 is essentially the physical media, right? This layer includes all of the physical equipment involved in the data transfer. So that's going to include cables, switches. It also is the layer where the data gets converted into a bit stream, which is a string of ones and zeros. So if you think about what we're sending at the very top, you have all of these kind of readable messages, and now we're getting to a point where we're actually switching ones and zeros in order to be, or sending signals via ones and zeros, either using electrical signals, radio waves like we talked about, light in the case of fiber optic. So this is like right at the lowest level, sending information on the wire. Okay, so 7 layers. Let's just go back up quickly. I want to show you this again. All right, just let it sink into your head a little bit. We'll start from the bottom this time. So layer one is easy. Layer one is just the physical connection, right? It's the cable, it's the wire, it's the or the radio wave, the wireless, whatever. It is the physical medium. Okay. Then we had layer 2, which is the data link layer. Okay. Layer 3, which was the network layer, and network layer we said was responsible for routing and packets. We had the transport layer, which essentially is creating the segments. And then we have the session layer, which is responsible for opening and creating and maintaining sessions. The presentation layer, which is dealing with compression and encryption and any sort of formatting changes that are required. And then layer 7 is the layer which you interact with the application. Okay, so you'll have these slides to go over if you want to at some point, but those are the seven layers.